Hey everyone, I'm Steven, CTO and co-founder of Cognition. Let's see. Sorry, give me a sec. Okay, there we go. Yeah, so a bit about myself. I think Nan did a great job introducing me already. Thank you. Started Cognition around 2 years ago, and the vision was AI is clearly getting better, and there's a lot of white-collar work, especially in code, that can be accelerated. And we just wanted to figure out how to do that best, reach the most people, have the most impact on the world. So that led us to creating Devin. Devin is an AI software engineer for existing code bases. And when I say existing code bases, this is really to distinguish Devin from some of the other tools you may have heard of. Tools that are great for kind of going from 0 to 1. You have an idea, like you want to make a landing page, you want to make an MVP of a product. There's a lot of great tools for that. But we wanted to really target the place where code happens at the largest scale. So large enterprise companies that use code to solve real-world problems. And I think everyone in this room can probably relate to that. Most of the code written in this world is written at large enterprises, and this code is powering systems that serve millions, billions of users. And this is the code that's also the most important to get right. So our founding story, we started out actually as an applied AI research lab. We had a lot of curiosity. We were like, all right, large language models, what are we going to do with them? We dabbled in a lot of the model training itself. We messed around with just talking a lot to these models. We would ask them math questions, we would ask them programming questions, just to really keep a pulse on how smart are they. And eventually, one thing that really clicked was we would have these problems, kind of like little algorithmic math problems. And we would give them to the AI and tell it to why don't you take a stab at this? It'd write out some code, and we'd run the code on the test cases. And we'd say, OK, we ran your code. There are 10 test cases, and you passed 5 out of them, and the other 5 you got wrong. Why don't you try again? And by doing this, we kind of created a feedback loop for the AI. And this is not something that the AIs have built into them, right? An LLM, if you think about it, it's a black box where you put in a prompt, and it spits out a response. Nothing in that has a native feedback loop. But we were the first to really think, this feedback loop is not that hard to orchestrate. You just take the response, parse out the code or whatever it's trying to run it, and feed the output of that code back in as an input to the next generation. And this small idea kind of evolved into a much larger system that is now Devin. Before I get into the details of how Devin actually works in practice, I want to give a big shout out to a lot of our customers. We have over 300 global customers, and some of these names might be familiar: Cisco, Verizon, AT&T. I think we have some representation in this room. And also, we have a lot of traction in the financial industry with Goldman Sachs, Santander, Citi, et cetera. Let's see. Seems like the slide might have been garbled a bit, but let's focus on the graphic here. What I want to show in this slide is really the landscape of AI tooling for engineering. So there's kind of 3 categories of AI coding tools. We have Tab Complete. This is kind of the earliest version where you maybe have GitHub Copilot in your editor. You type a few words, you start defining a function, and it'll complete the function definition for you. Then we have agentic IDEs. These came around maybe earlier this year. Windsurf was the first one, where you could really just tell the AI what you wanted to do, and it would kind of do it for you. And this is really coming out of advanced tool use that the models had picked up. And finally, we have autonomous agents like Devin. This is, I'd say, the most complex beast of these 3. This is where you don't even need a human in the driver's seat. The previous two categories are really like co-pilot tools, where you have a human in the driver's seat and you have an AI assisting them. Devin flips that on its head. Devin's in the driver's seat. That's the main difference here. And the human is more like, I don't know, in the passenger seat or in the back of the car, whatever the analogy becomes. And the human's more just telling Devin where to go, what to do. And Devin's really hands-on keyboard doing everything. So this is a paradigm shift. If you're trying to build a Copilot product, you really only see something like 20% speed gains. Now, I'll get more into that later of why it's only 20%. But if you're really delegating entire tasks to autonomous agents like Devin, you can get much, much larger gains. The slides say 6 to 12x. These numbers are just estimates. What you really want to imagine is if you have a backlog of like 100, maybe low priority things to fix about your product, these are tasks that probably won't get done for the most part, right? You have your P2s and P3s, your low priority backlog items. By default, they're not getting done. But when you have autonomous agents, it doesn't require much human investment to just say, hey, let's spin up 100 Devins to tackle these 100 tasks. And then they'll just do it in the background. You don't need a human piloting these agents. These agents just do the task. When they're done, they'll verify their own work. They'll prove that they did it correctly. Or if they didn't do it correctly, it'll be self-evident. And then you kind of just get free productivity from that without needing to match that investment with human time. So that's where the multiplier comes from. We're really measuring for like a single ounce of human investment, how much impact do they have? What is the leverage? What's the ROI? So this graphic is kind of a nice visualization of, you can have, Devin is working in its machine. It's using the same tools that a human would use, a browser, an editor, and then you can have like 10 of them, all running at once, or 1,000. And this is the main product that we sell to enterprises. They use it for large-scale migrations, refactors, modernization in general. OK, so now that's where we are today. And this is the product that we have been selling. And I want to actually take a sec to talk about where we're headed. And really, it all boils down to this, which is that engineering is not the same as coding. Implementation is what, it's what you think about when you think coding. You see in the movies, like, you got the elite hacker on the computer typing really fast and like lines of code scrolling through their monitor. But that's not really it. Engineering is a lot more than just writing code. What's actually going on is testing, planning, QA, maintenance, but most of all, understanding. Understanding is the thing that separates a good engineer from a bad engineer. And this is really one of the theses that we're doubling down on at Cognition. Full loop engineering. We're no longer just focused on the implementation step. We really want to break down the engineering lifecycle into these phases. Some people know this as the software development lifecycle, the SDLC. But you really got to understand your code and how it works. Then you got to plan out your change. And only then can you implement and review and test the change. So yeah, let's dive into each of these steps. Understanding. So understanding is actually kind of near and dear to my heart. And as I said earlier, understanding code is really what separates the best engineers from the median engineers. The best engineers I know, they can just take a piece of code, kind of skim it, and they just know what's going on. Like, it's not because they read more words per second. It's because they know what to focus on. Because their brains are already predicting how the code works just from a few pieces of data. They kind of already have good approximations of everything. And then as they're reading more and more of the code, it's just clicking. It's like, yes, this is what I expected. That's a surprise, right? Understanding code is the way you tell if someone actually knows and has experience coding. But we want to democratize that. So we built DeepWiki. DeepWiki is DeepWiki is one of the side products that we built and shipped, more as a kind of like a marketing play, kind of as a public service. We took all the repos on GitHub, all the ones that were popular, and we made them available for free as wikis. And these are wikis that are automatically generated with our AI code-based understanding algorithms to kind of paint a macro structure, give a system architecture overview to anyone who might be curious. So you can take, for example, like PyTorch or VS Code or Django, Mongo, any number of these great open source projects. And now you just go to deepwiki.com. You can try this on your phone, by the way. Just go to deepwiki.com and start asking questions to these repos. And you'll get very high quality answers about like how exactly things work in this repo. And let's see, this is a quick animated demo of what it looks like to read through a pre-generated wiki. You can see there's diagrams that show the architecture of how the code base works, and there's many pages that all link together, kind of like Wikipedia. Okay, so that's understanding. I want to move on to planning now. So planning and understanding, you can't really separate the two. Planning, I'd say, it's the thing that happens in your head. Once you've understood the code and you know what you want to do to the code, like let's say, for example, you want to make your website load faster. First, you got to understand, which page, how is it being loaded, what is it being served through, are there any slow network connections anywhere, perhaps, and do you need to move to a different like CDN or something? But actually planning out the change means taking your understanding and turning that background information into kind of a foreground narrative of like, so what are we going to do, right? And planning out a change is, in that sense, strictly downstream of understanding. So we built Ask Devin. Ask Devin, it straddles both the understanding and planning steps, but the main idea is you can be very targeted about, I have this question. I really want to change, let's say, the garbage collector. Let's first figure out how it works, and then let's write a ticket about what exactly we're trying to do. Then you send that to Devin, and it'll combine the understanding of how it currently works with what you're trying to do. And it'll give you a very actionable plan that you can then say, like, yes, this looks good. Please do this for me, Devin. And that is how you kind of connect the plan to writing the code. There's this key review step where the human is in the loop saying, like, yes, this plan looks good. It seems like you understood what I was trying to say, and the plan looks like something I would do if I were to do it myself. Let's see, I actually want to, quick check for time. Yeah, I want to get to the last part, because this is honestly some of the most exciting stuff that we've been doing. The difference between the Gen AI era and the Gen AI plus reinforcement learning era. At the high level, generative AI, this is like ChatGPT from 2023. You talk to a model and it just knows basically everything. Gen AI plus reinforcement learning is the advent of tool use and goal-oriented behavior, where your AIs can take a task and really like, almost like a human, just like move towards the goal. Right? It's not just answering trivia questions or answering math questions. It's actually taking actions. It's using tools, exploring. If it's like, I don't see all the code I need to see, it'll run a search command. It'll run open file, or it'll list the directory. It'll take steps to improve its own understanding of its environment if that furthers its goal. And this has really unlocked basically all these advancements in AI coding. And I want to show one pretty cool demo. Basically, this is an example of us using Devin, where we said, hey, for the Ask Devin page, this is us working on our internal product. We're telling it to kind of change the document title. And here, this is a screen recording that Devin then sent at the end after it successfully completed the change. This is a screen recording that Devin created for the purpose of proving and demonstrating to the human, its manager, that it did the task successfully. So to let that sink in, this is a video recording that Devin created of itself testing the change it made. This is what I was alluding to when I was saying it's pretty self-evident when you assign a task to Devin whether it succeeded or not, right? And this is pretty different if you've actually used AI coding tools recently. This is pretty different from what we have today, where you kind of have to read the code yourself and test yourself. Like humans are still in the loop for the most part when using agentic coding, but where we're headed is autonomous verification and testing. And just to highlight a few things, Devin's using the developer console here, kind of like a real software engineer would. Here is typing document.title to really validate that whatever code it wrote actually took effect. OK, I think we're running a bit short on time, so I'll just kind of breeze through the last few. PR review is a very important stage of software development, obviously. You have to make sure the code getting committed to your repos is high quality, meets your style guidelines, passes your tests, et cetera. We have a lot going on here, but it's maybe a bit less unique, I think. It's what you'd expect. The AI will look at the PR and review it and tell you, any bugs it found. It'll also make it easier for the humans who look at the PR to review it as well, just by organizing all the changes that happened into a very logical structure. Guardrails and security. I mean, this is basically the enterprise slide. Like, we started out as a research lab, and then we kind of were pulled in this direction by all the customers that we were selling to. And they're like, you guys have really cool tech, but we need a lot of things if you want to actually deploy in places like Goldman Sachs. And yeah, we built a lot of guardrails. Some of these are classical security networking things, like deploy Devin in your private cloud. Other things are more AI. So this is like written rules for the AI to never do X, like never upload your code to untrusted website, things like that. And it's kind of crazy that that's even necessary. But with the amount of autonomy we give our agents, we do need to set like both hard and soft guardrails to make sure it doesn't misbehave and break your systems. OK. How are we doing on time? I think now's a good time to honestly pause and maybe just conclude here. Yeah, thank you everyone for having me here and listening. And yeah, this is a great group, and I'd love to take any questions now. Yeah. Thank you. All right. Yeah. Yeah, the question was, have we thought about expanding a lot of what we've done into user documentation? So not just for your internal team working on the product, but for the users who are buying your product? Yeah, I think we definitely have. The first step we took was expanding it to things like Ask Devin and DeepWiki, making that available to non-engineers, but engineering-adjacent orgs, so like data science and support, who maybe interface more directly with the users. Data science support, and of course, like sales and go-to-market. Now, the sales team doesn't have to ask the engineering team every time they have a question about how exactly does this feature work. And yes, the logical next step is to make it more user-facing. There's definitely some concerns where maybe you don't want to tell the users, like, yeah, actually, this thing that we're charging you $20 a month for only costs us like 5 cents a month. Like, there's some, there's definitely some intentional information hiding going on there. Yeah, question.
Yeah, it's a two-part question. One is the wiki page. Does that take your existing code and then like document it out for you? And the second question is, are there specific coding languages that Devin is especially good at? What are the top, in order, like which ones is he especially good at?
Right, I'll repeat the question. So first part was, does Devin generate documentation from your code?
Yeah, on the wiki page.
On the wiki?
Yeah.
The wiki, the way it works is you just you upload a repo basically, or you give Devin access to this repo, in the case of open source repos, they didn't have to do anything. It's already free, so we just kind of crawled it. And then, yeah, we just take the repo. We look at not just the code in the repo, but also all the history, all the Git commits that led up to this, all the discussion that happened, all the changes and evolution. And from that, we kind of learn how the code base actually works, right? And this deep wiki, I think, is one of the things that I think most people are most impressed by. And I've heard a lot of people in the space saying like, oh, we really want to replicate deep wiki. Unfortunately for them, we haven't really shared all the algorithmic secrets of how we did that. But yes, it's just all coming from the code base. There's very little human involvement. And the second question. Languages Devin is good at. Yeah, I mean, it's pretty much pretty strongly correlated with the languages that are commonly used. Because as you know, Devin's powered by LLMs, and they're trained on a lot of code based on what's available out there. I would say Devin does specialize in areas where there's a strong feedback loop. So it's not really about the language, but more about the quality of your code and your testing coverage. If you have really comprehensive unit tests, Devin can do test-driven development, and it's just much more likely that it'll arrive at a change that actually works. Versus if it's just writing code and praying that it works without testing it, it's much more hit or miss. Yes? Yeah, how is Devin different from other vibe coding tools out there? Let me quickly go back to the earlier slides. By and large, other vibe coding tools focus on, let's see, just one of these parts of the loop. We focus on all of them. And I think we also do, like, in terms of pure results, probably a better job at each individually, though, I mean, I'm also a bit biased. Yeah, I think where we really distinguish ourselves is in the understanding stage, understanding the code. And this isn't just about like the AI understands the code. This is about we build tools for the human to use so the humans understand the code better. Because our thesis is really like, if the human doesn't know what they're doing, it doesn't matter how good the AI is, right? The human will kind of pilot their AI maybe like off a cliff or something, right? So I'd say that's one of our biggest differences. We really focus on understanding, and that's very also correlated with working in large, mature, enterprise scale code bases. Yeah.
Quick question on security, right? Do you have specialized security audit agents, especially when you're dealing with cryptographic protocols, right? Because it's like you screw up the cryptographic implementation, you're fucked with a capital F.
Yeah, okay, so the question is, do we have specialized security agents for when dealing with
security audits? Yeah.
Security audits. Yeah, so security is like basically one of the top like 3 things that enterprises care about. So it always comes up. I wouldn't say we have reached a point where we're using Devin to write like new cryptographic primitives, for example. Never roll your own crypto, right? And rather, I'd say Devin is very good at like staying on top of your vulnerabilities. So there's tools out there like Snyk. Maybe some of you guys use Snyk, SNYK. It will tell you like, oh, this dependency that you're using, this third-party library, there's a vulnerability that's been disclosed about it. You better upgrade it to the latest version that fixes it. And Devin will kind of tell you like, no, this like you've already done that. This is a false alarm. These classical tools are very flaky, right? Like I think that's more in line with how we see Devin fitting in there. It's really up to the humans whether they want to trust an AI to write their most sensitive code. Yeah, question.
So one last question. I'm not trying to be funny, but how far can Devin go? Can I ask it to write NAS platform orchestration software? How far does it go?
Yeah, I mean, no, that's a great question. Like, how far can Devin go? I mean, there's only one way to find out, right? Why don't you just, get Devin and give it some tasks? I think you'd be surprised. Devin is not really limited, except in the ways that you choose to constrain it. So if doing this NASDAQ thing requires giving it the keys to your production database, then you might decide, like, I don't want Devin to be able to do this because of what that might imply. But like generally speaking, Devin has a fully functional computer. It can use the web, it can run commands, it can even like create VMs if it needs to run in Windows or Mac or something. It can basically do everything a competent human could do. Though its judgment is, where it usually tends to need more support from the human.
Question here.
Yeah, okay, you first.
Super exciting. So the question is, white coding apart, those are for, generic population to kind of do some, tools and build tools that are interesting, but your platform is really for deeper engineering projects, isn't it?
Yeah.
That's the big difference. That's what you're aiming for, right? These are deeper engineering problems or systems that companies can use Devin to build. It's not white coding platform.
Yeah. The question was like, are you a vibe coding platform or more targeting professional engineers? And let me just go back to the beginning. Devin is an AI software engineer for existing code bases. And the other tools like Lovable that you mentioned are tools from going from 0 to 1, where you don't have any code and you want to just bootstrap an application from scratch, and it'll just use a very simple template, but it's not really something you could integrate into an existing product. And we focus, sorry, this is the slide I want to show. And we focus on selling to large enterprises who have these real problems. I wouldn't say vibe coding is exclusively the domain of hobbyists or like non-professionals. I'd say there's this concept of a professional vibe coder, and I'm kind of guilty of being one myself, where most of my code is written with me like using Devin to like write the code, but it's me piloting Devin, and most of all, like I have the understanding that I think is necessary to actually do a good job.
All right, I think we need to end, and just he'll be around at just maybe a few minutes, and then if anybody have a question, please ask him. So thank you, Stephen.
Thanks so much, man.